Let us go ahead in tangents and let us take a question. Now, before I do this question, I would like to introduce a small aspect of the equation of tangents. Now, we know that if this is a circle that we're talking about, let's say it is x square plus y square equals to a square, and this is the tangent associated with it. This is, I have taken y equals to mx plus c, and let's say this is 0 comma 0. So, ultimately, this is what we have, and this is the associated equation. Now let us say that this is the point that we're talking about, x1, y1. And from here, we're drawing a pair of tangents. And I want to now link up this part. So we just said that y equals to mx plus minus a root 1 plus m square. This would be the equation of the tangents. Plus will correspond to one tangent, minus will correspond to another tangent. Now that's the case. We can surely say that if I transform mx on the other side, it's going to look like this: y equals to y minus mx equals to plus minus a root 1 plus m square. So let's square on both the sides. If we square on both the sides, it's going to be y minus mx the whole square is equal to a square into 1 plus m square. Now let's rewrite this equation. If I rewrite this equation, it's going to be y square plus m square x square minus 2y mx equals to a square plus a square m square. Let's rearrange it in the form of quadratic of m. If we rearrange, then we're going to get m square, x square minus a square minus 2y mx plus y square minus a square equals to 0. This is what we're going to get. Now once we write this equation, what information is this giving us regarding the slopes? So we know that from here, this, if we have a quadratic, let's say ax square plus bx plus c equals to 0, we can always write the sum of the roots of this alpha and beta as minus b by a, and product of the roots is c by a. Now, if I want to apply the similar part over here, then what will happen is sum of the roots that we're going to get is m1 plus m2, because there's a quadratic equation in m. So m1 plus m2 is what? That is b by a. So that's going to be looking like 2m 2xy divided by x square minus a square. This is sum of the roots. Product of the roots is going to be like m1 m2 is going to be y square minus a square by x square minus a square. So we are going to use this as and when required. So let's say we are having two tangents, and the two tangents are such that there is a point from which, if you draw the tangent, they are always perpendicular. Something like this. So there is one point from which, if you draw the tangents are always perpendicular. But it's not just one point. If you keep moving this point, then you'll realize that this point, from any point on this circle, if you draw that particular pair of tangents, they're always going to be perpendicular. Now, how to find that? Now, this clearly is a circle, and this is called locus of the moving point. So, this is the point P. This point constantly moves, and that is called locus. If you want to find the equation of that locus, then I can clearly say that m1 m2 is minus 1. Why m1 m2 is minus 1? Because we are drawing a pair of tangents which are perpendicular. Now this is the clear equation. If this is the equation that we have, then I can write x square minus a square is equal to negative of y square minus a square. So if you rearrange it, it will come out as x square plus y square equals to 2a square. That is the equation of the circle that we're talking about. So if this is a, then this is certainly root 2a. So the equation of the circle is x square plus y square equals to 2a square. And this equation is called equation of director circle. So this term is going to come often. You can remember this from here onwards as if we have a circle x square plus y square equals to a square, then its director circle equation is given as x square plus y square equals to 2a square. And this radius is root 2a. Now we have spent enough time talking about the tangents. Let us spend some time having a discussion on the normals as well. So let us say that this is one circle. Again, x square plus y square equals to a square. And you are drawing a tangent to this part. Now if this is the tangent, then this is definitely the normal. So let's say, instead of taking x square plus y square equals to a square, let me take it as minus d comma minus f. And this point is some x1, y1. So we can surely write the equation of the normal given that slope is there with us. So y minus y1 equals to m. M is definitely going to be y1 plus f by x1 plus g. This into x minus x1. This is the equation of the normal. Now if you know that this is the equation of the normal, then certainly once we have the slope and the point, we can write its equation. So we can definitely take some questions and try and understand this in a better way. Let us say that we have the circle given as 2x square plus 2y square minus 2x minus 5y plus 3 equals to 0. Find the equation of the normal. At 1, 1. So that's what is given to us. Clearly, I can now write the equation. But first of all, I have to rearrange this circle. So if I rearrange this circle, it will be x square plus y square minus x minus 5 by 2 y plus 3 by 2 equals to 0. So I can find out the center from here. The center comes out as half comma 5 by 4. This is the center of the circle. Once I know that, the equation of the normal can be found out. Because I know that this particular point is given to us as 1, 1. And this point is also known to us half comma 5 by 4. So we can find a slope of this normal as 5 by 4 minus 1 by half minus 1, which is 1 by 4 by minus half. So the slope is coming out as minus half, which means that now I can write the equation. So equation is going to be y minus 1 equals to minus half into x minus 1. So rearranging, I'll be getting this part, that is x plus 2y is equal to 3. That is the equation of the normal. So this time around what's given to us is, there is a circle of which one of its diameter is given to us. So diameter is given as 2x minus y equals to 2. And it has another normal drawn to it. So normal is drawn this way. Now to understand one fact, that normal of the circle always passes through its center. So it is along the radius. So one of the point lying on this is given to us, which is 4, 3. And this normal is drawn at this point, 2, 1. We have to find the equation of the circle. Now one thing over here to be understood is that if one of its diameter is given to us, then if we find the equation of this line and we solve this line and this line together simultaneously, what we'll get is a center. Once we get the center, The distance between center and this point can be obviously be found out, and that is the radius. Once you have the center and radius, we can surely write the equation of the circle. So let's do it. Given that this equation of the normal over here, we can find, to find that we need a slope. And these 2 points are going to help us out. So slope of this normal is going to be 1 minus 3 by 2 minus 4, which comes out as minus 2 by minus 2, which is 1. So once you have the slope, we have the point also, we can write the equation. Y minus 1 equals to 1 into x minus 2. That is y minus 1 equals to x minus 2. That means x minus y equals to 1. This is the equation of this line. The equation of this line is already given to us. Solve them together. So if we solve them together, what we are going to find out is the center. X is equal to 3. So we know that x is, okay, we are subtracting this. So x is going to be 1. If x is 1, y is 0. X is 1, y is 0. That means the center of the circle is nothing but 1, 0. Once you have this point, it's going to be x minus 1 the whole square plus y square is equal to the radius. So radius obviously from here comes out as 2. That is the distance between these 2 points. The radius is root 2. Square of it is coming as 2. So now we have another equation which says that two parallel tangents to a given circle are cut by a third tangent in the points R and Q. In the points R and Q. Prove that the lines from R and Q to the center of the circle are mutually perpendicular. So let's understand how the situation is. Let's say this is a circle that we're talking about. This is one tangent and this is another tangent. So we have the freedom, given that specific tangents are not given to us, so we have the freedom to choose the tangents the way we want. Just that, they have to be parallel. So this is my 0, 0. Let's say this point, I'm choosing over here now that my circle is x squared plus y squared equals to a squared. Center is at origin, radius is a. And I know that this line obviously is y equals to a. This line obviously is y equals to minus a. Given that this point is 0, a, this point is 0, minus a. Now, at any random point, let's say this point, I am drawing a tangent. Now what is happening? As per the condition, this tangent, the third tangent, is cutting the previous two tangent at the points R and Q. So let's say that this point is R, this point is Q. Once we know this part, we can definitely find R and Q by standard coordinate geometry. So let me, as we have said earlier, any general point over here can obviously be taken as a cos theta, a sin theta, which is called the parametric form of this tangent. The circle. And we can write the equation with this particular tangent now as x cos theta plus y sin theta is equal to a. So we know that this tangent is this. Now obviously if I want to find R, this point R, which is having an intersection at y equals to a, let's put y equals to a over here. So what will happen? X cos theta is equal to a minus a sin theta. So x is achieved, that is a minus a cos theta by cos theta. This is x. Obviously R is known to us, so R becomes a minus a sin theta by cos theta, comma a. And similarly, now we can find Q. So to find that, we have to find a point of intersection of this tangent and y equals to minus a. So over here, I'm going to put y equals to minus a. And what that does is x cos theta equals to a plus a sin theta. That will give us x equals to a plus a sin theta divided by cos theta. So that is x. Again we will write it, and we get the point Q now as a plus a sin theta by cos theta, comma minus a. Great, so we have got points R and Q. And now the lines which are connecting this, we can surely say from here. And we can prove it because we have the points now. This and this. We can find the slope of this. We can find the slope of this. So let's find M1 and M2. So the next thing that we are going to find out is the slope. In order to do that, let me just rub this part. So we have got the 2 points now. Let's say the slope of, let's call this O, the slope of OR is going to be A by A into 1 minus sin theta by cos theta. So if we rearrange it, we are going to get cos theta by 1 minus sin theta. And M of OQ similarly is going to be cos theta by 1 plus sin theta. Now clearly, if we multiply MOR into MOQ, what will happen? We are going to get cos square theta on top, and this is going to be 1 minus sin square theta. Okay, there is one change though. M of OQ will definitely have a negative sign because of this minus a, which are not considered. And so here also while multiplying, we are going to have a negative sign. Now you know that cos square theta and 1 minus sin square theta is the same. So we can cancel it out and we get MOR into MOQ as minus 1, which proves that these two lines are perpendicular. That's what was asked. Prove that the lines from R and Q to the center of the circle are mutually perpendicular. Hence proved.